Hi everyone. Today we are doing break-even analysis. This is a very important concept for business because we all care about when our business is moving, that pivotal point where it moves from losing money to earning money, where it goes from loss to profit. This, my fine folks, is called the break-even point. So let's look at a few examples and two different techniques for finding that break-even point. So example one says, a company produces specialized calculators for exceptional learners. They are $300 each. They sell 100 calculators per month. Okay, so let's start off with what some of these numbers mean. So the fact that they sell 100 calculators is their capacity. This is their capacity. And they sell these calculators for $300 each. So our revenue is dictated by 300 times how many calculators we sell. Okay, I'm going to write this as our total revenue is equal to $300 times every calculator we sell. We don't know how many calculators are being sold. We know our maximum capacity of sales is 100. That means that our business can't produce more than these 100 calculators, but we know that we pull in $300 every time we sell one of these calculators. Part B, fixed costs for producing the calculators are $7,000 per month, and it is $150 to produce each calculator in costs. Write a formula that represents costs. All right. So anytime we're talking about costs, there are two parts to this. The first is the fixed, and the second is what I'm going to call the variable. Now, fixed costs are costs that don't change. They are the costs that are going to be in play. Like, it doesn't matter if I sell 0 calculators or if I sell 50 calculators, those costs are always there. So, maybe we have to pay rent on the facility that we're in. Maybe we have hydro. Maybe we have payroll. These are things that are not going to change. And then the second are variable costs. Now, variable would be the buttons on the calculator and the motherboard that goes into this calculator. So every time we build a calculator, we have to buy that particular product, its buttons and its motherboard and its casing and all of those things. So this variable cost changes depending on how many calculators are actually produced. So if I was to write this algebraically, we have this flat $7,000 that doesn't change, it's just there. Plus, every time we make a calculator, there are $150 worth of components that have to be put into it. So again, cost always has two parts, the fixed and the variable, and so your cost function is going to be a little bit more complicated than your revenue function. Now, what are we going to do with these two equations or these two functions? Well, I'm going to start off by writing this as total cost is equal to 7,000 plus 150x. Okay, we're going to create a table of values and we're going to graph it. And I'm going to have you do this in Excel for your assignment in the next lesson. But for now, we're just going to do it by hand so you can see how you have to input it into Excel as well. So I'm going to set up a table of values for revenue and a table of values for costs. All right, so we have how many calculators, so the number of calculators that we sell, and we have total revenue, and our total revenue is equal to 300x, and we have the second one that we're going to look at in a minute, which is total cost 7,000 plus 150x. All right, so we're going to set up a table of values. Now for a table of values, we need to decide what to let x be. We need to, how many calculators, well, we could sell 0 for sure. And that's basically our minimum. This is our minimum. And our maximum, well, we can sell a maximum of 100 calculators. We can't go over capacity. Our manufacturing process only allows us to get those 100 calculators in. And then I always just choose some random number in between, usually the halfway mark. So I'm going to choose 50. But clearly the minimum and maximum have to be in play, and you need a third one just as a double check that you haven't made a mistake. You should always have 3 values, not 2, so that you have 3 dots that line up in a row, because you won't catch a mistake if you only have 2. All right, now we're going to substitute in to what our revenue is here. So we're going to substitute in, so this will be 300 times 0. So if we sell 0 calculators, we make $0. And this one will be 300 times 50. So if we sell 300 calculators, we will make $15,000. And if we sell 100 calculators, we will make $30,000. Now while we're here, let's also do the same for our cost. Remember, this is our cost. This substitution is a little bit trickier, but nothing we can't handle. So this will be $7,000 plus 150 times 0. And if we put that in our handy calculator, we get $7,000. So if we sell 0 calculators, we have costs that are 7,000. And this will be 7,000 plus 150 times 50. So 14,500. And this one is 7,000 plus 150. What if we sell 100 calculators? How much will it cost us? $22,000. All right, now we're going to graph both of these lines. We're going to graph them as ordered pairs. Let's go down to the grid that I've provided here. Let's start off with our scale. So clearly the X scale has to go up to 100 calculators, right? This is our X. How many calculators are we producing? And our maximum is 100, so we've got to get to 100. There's no right or wrong scale, but you want to try and use as much of the grid as possible. I believe that if we count by tens, that we can fill this scale up. Now, the Y scale is for both. It is for both the revenue and the cost. So you have to look for your biggest number. So our biggest number in the revenue column is 30,000. And our biggest number in the cost column is 20,000. These two numbers, those are our bigger numbers. So 30,000 is the biggest. So I got to make my scale go up to 30,000. I'm just going to dictate that I'm counting by thousands by like adding in those 3 zeros. And we've got to go essentially to 30 then. So can we count by 5s? 5, 10, 15, 20, 25, 30. Yep. Can we count by 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. No. Okay, so it looks like we can count by 5s. We could probably count by 3s. 3, 6, 9, 10, 12. I mean, that won't fit either. Okay, so let's count by 5s. And we are graphing here our break even. Let's give it a title for our calculator business. And let's start off with the revenue. So here's our revenue dots. So we have 0, 0. I'm getting it from 0, 0 and 50, 15,000. 50, 15,000 and 100, 30,000. All right, so I can plot those. Some of them we'll have to estimate, but in general, we can do this fairly accurately. So 0, 0 is here. 50, 15,000 right here. And 100, 30,000 here. Okay, and like I said, we do 3 dots so that we can see that we have created a straight line, that we haven't made a mistake. And I'm just going to label this as total revenue is equal to 300x. Now let's do the same for our cost. Okay, so what are my ordered pairs for cost? Well, we have 0, 7,000. And 50, 14,500. And 100, 22,000. All right, so now we can graph those. So 0, 7,000, we're going to have to estimate this one. 50, 14,500, we also have to estimate that one. And 100, 22,000, and we have to estimate that one. And again, these should line up in a straight line. And this is our total cost is equal to, what was our function? 7,000 plus 150x. All right, now, if you look in magazines, business magazines or reports, you're going to see this kind of graph be produced. This is a standard break-even analysis graph. And there are other parts that I want to show you exist here. So what is often labeled is just the profit, and often that might be shaded, and the loss, and this is the break-even point. That is where we shift from losing money to making money. And then there's one other line that is often put in, and that is our fixed cost line. So if I know at 7,000 that I had fixed costs, often this is also put into the representation of our break-even graphs. Okay, so this essentially is what you're going to produce for me in Excel in your next assignment. Now that we see how we can graphically represent it, I want to show you how we also algebraically find what this break-even point is. Now, we have a sense of what the break-even point is from our sketch here, and if we had taken the time to have a really accurate axes and we'd used a ruler instead of like sketching it out, it would be really quite accurate. But if we want to know what this exact point is, we can use algebra. So we're going to algebraically solve for the break-even point. There's two ways that we can look at the break-even point. We can look at it using the notion that profit is equal to revenue minus cost. We can look at it that way. And if we're breaking even, then our profit is zero. We can say that, this is zero is equal to revenue minus cost. And in doing so, then we can just say if we want to find the break-even point where profit is zero, it essentially is just cost is equal to revenue. That's how we're going to, in the easiest way, find the break-even. So we're going to use this notion that cost is equal to revenue, or we're representing that as total cost is equal to total revenue. All right, well, what is total cost? Well, we had an equation for that. I'm just going to give myself some more space here. So we have an equation for total cost, and we have an equation for total revenue. Total cost was 7,000 plus 150x. And total revenue is 300x, right? There's our total cost, there's our total revenue, and I'm just putting the equations in for the variable representation. All right, so now if I do some algebra, if I subtract 150x on both sides of the equation, that leaves me with 7,000 is equal to 150x. And 150x means 150 times x. So if I divide both sides by 150, I get x is equal to 46.6 repeating. Okay, so we know that if we make 46.6 repeating calculators that we're going to break even. Now, if we're reporting this, clearly we're going to say, well, we need to make 47 calculators. We don't break even at 46 calculators. We haven't made enough. At 47, we're a little bit over, but like we're selling calculators, so we can't sell a part of a calculator. But it's in the theoretical way of looking at it, we can report our break-even point as 46.6. What will like the amount of money be? How much money will be in our revenue at the point that we make these 46.6 calculators? So we know that total revenue is 300 times x. So if we want to know how much money we would have taken into the company by making 46.6 calculators, we can just times that by 300. $14,000. All right, so what does this break-even point mean? So this means that when we produce 46.6 calculators, we break even. Revenue will equal total costs at that point. They are the same, which is $14,000. And you can see from my graph that because I sketched it, my break-even point looks closer to 40, but we can label it here as 46.7 and 14,000. And again, if you were reporting this, it clearly would be that you had to make 47 calculators. All right. Now I would like you to attempt this next example. Stop the video and try it on your own, just as I have done above, and come back and I will walk you through your solution to see how you did. So please do take a moment and try this one on your own. All right, I'm going to solve this one now, and I'm going to go a little bit quicker. It says Designa, a hair designing salon, has an average of 300 customers per week. Okay, so we're going to consider that our maximum capacity. Each customer spends an average of $50 a visit. So our revenue that we can pull in here is $50 on average for every person that walks through the door. The fixed costs for the salon are $3,000 and $25 in labor. So if we have somebody come into our salon, we have some costs that we can't change, like rent of $3,000. Plus, we have some expenses that are associated with the services, like the lotions and the wax and things like that. All right, so now we're going to set up a table of values. X is equal to the number of customers. We have revenue. Total revenue is 50x. And we have total costs is 3,000 plus 25x. And we're going to create a table of values. And recall that you have to do 3 points, not 2. All right, and what is our maximum number of customers again? Why it was 300. So we can have 0 folks walk in, we can have a maximum of 300, and then you should have selected some number in between. I'm going to roll with 150 because it's a nice number in between. All right, 0 customers gives you 0 income. This is 7,500. And 15,000. And then we can do the same for our costs. 0 customers is 3,000. $150 customers is 6,750. And 10,500. All right, and then you would have taken these 2 equations to your table or your graph, taken your table of values to your graph, and we're going to say that our X is the number of customers. We know that we have to get to 300 customers, so we have to go from 0 to 300. 10, 20, 30, 40, 50, 60, 70, 80, 91. It's not going to work. Maybe we can count by 20s. 20, 40, 60, 80, 1, 120, 140, 160, 180, 2, 240. So we've put in our number of customers. We know that on the y-axis we have total revenue and total costs, and perhaps I will count by thousands again to keep it a little bit cleaner. And we've got to get to 15,000. So we could 1, 2. All right, and now we can graph our two lines. For our revenue, we have 0, 0, 150, and 7,500. $315,000. Okay, and we can draw our line. And this is total revenue is equal to 50x. Costs, 0, 3,000, 150, and 6,750. And 310,500. And this is total cost is 3,000 plus 25x. All right. And if you have labeled this up properly, you will have said that this is our profit zone. This is our loss. And we also have a fixed cost line of 3,000. All right, and then the last thing that you should have done for me here was determine what is this precise break-even point so we can label it up. To find break-even, we're going to say total revenue is total cost. So we have 50x is equal to 3,000 plus 25x. We're going to do some algebra, subtract 25x off of both sides of the equation, leaving us with 25x. 50 minus 25 is 25, equals 3,000, and x is equal to 120 customers. Looks like our graph is pretty accurate. All right, so we have 120 customers. Now, what will our revenue and our costs both be equal to at that point? Well, let's substitute into the revenue. It doesn't matter which one you choose. They're going to give you the same answer, but we'll do the revenue because it's easier. So 50 times 120 is $6,000. All right, so at this point, this particular company is going to break even with 120 customers and revenue that's equal to cost, which is equal to $6,000. So hopefully you were able to do that one successfully. I'm going to end this video and start another one with example 3.